In this video, I'll be going into detail of how patches can be configured in Addivox. Addivox is an additive synthesizer, meaning it builds its sounds using component sine waves, one for each harmonic. And if you're familiar with a spectrum analyzer, it's kind of like that, but in reverse. A spectrum analyzer takes a sound and breaks it down into its component frequencies. An additive synthesizer uses component frequencies to build a sound. Now, additive synthesis is very flexible, but this can come at the cost of complexity, and it may not be immediately obvious how editing a patch in Addivox works, so in this video I hope to demystify it. If you haven't seen the intro video to Addivox yet, you might want to go watch that one first, since it gives a quick overview with more musical examples. This video will be a bit longer, and I'll just be playing a lot of notes between G and C because that leaves my right hand free to use the computer. I'm going to start with this minimal patch with just a sine wave. And to begin, we'll need to enter edit mode. Now, I'm going to skip this tab of edit mode, the EQ tab, because that's an interesting one. It's a bit different from the rest, and I think it deserves its own video. So I'll move on to the level tab. And this shows the harmonics that will be played. And there's currently just one, the fundamental here. Let's add a few more. When I hover over a bar, its value is shown at the top, and the harmonic number is shown at the bottom. Now when I switch back to the visualization mode, we can see those harmonics that I added. I can also see that when I play with a lot of breath, the output meter down here is getting into the red. This means that the output level is getting too high, and whether or not this is going to cause clipping will depend on your system and audio driver, but it's safest to stay below this. So I'll go back into edit mode and lower everything. The actions menu here has a number of things you can do to the settings, including scale down, which has a keyboard shortcut of A. So I will just keep doing that until full breath no longer gets into the red. That's better, but these bars are looking pretty small. We can fix that by changing the y-axis transformation. Because perceived loudness is logarithmic, the pseudo-log transform makes sense for these level controls. It's pseudo-log because these go all the way to 0. A true log transform can show 0. Now I can try drawing different harmonic profiles here to see how they sound. The different edit modes give you some options for working with the harmonic profile. Nudge can let you make fine adjustments. Smooth does some local averaging. And draw a line lets you set a range of values all at once. Also, Addivox is full of tooltips, so if you're not sure what something does, just hover the mouse over it and you'll see an explanation. Like that. So for this demo, let's make a harmonic profile that starts around here. It peaks at harmonic 10, and then it tapers down to harmonic 70. Then I'll smooth it out a bit. And then I'll reduce the even harmonics by putting on even mode here, so my edits only affect even harmonics. And I'll nudge those down to create a bit more of a square wave sound that comes with the odd harmonic bias. And if I switch back to the visualization, we can see this profile. Okay, let's move on to the next edit tab, breath. Just like the level tab, this lets you set the parameter separately for each of the harmonics. And this is true of all the tabs we're looking at today. They all give per harmonic control. At the moment, these are all set to a value of 2, and the maximum is 100, so the bars look pretty small, so I'll use a y-axis transform again. The square root transform is less strong than the pseudo-log transform, but shows the low values a bit more clearly. And again, this didn't change the values. They are all still 2. It just changed how the bars are scaled. Now, this setting controls the relationship between my breath input and the harmonics level. One way to think of it is how much breath will it take before the harmonic becomes audible. So if I set these all to something around 10, it will take more breath before we can hear them. Watch this breath meter here while I play. Now we can't hear anything in the lower half of the breath range, and the note comes in very quickly at the top end. If I set them all to a low value, like 0.5, now the harmonics all come in at very low breath levels. And so far, I've been drawing a flat curve where all harmonics respond to breath in the same way, but it gets more interesting when different harmonics behave differently. So I'll make the first harmonic have a setting of about 1, so it comes in with not very much breath, and then ramp up to a full value at harmonic 70, which is the highest harmonic in this patch. Now the timbre of the note changes with breath, getting brighter as I blow harder. You can see this in the visualization. In some other software synthesizers set up to work with Wind Controller, the breath is often used to control the frequency of a low-pass filter, and the way it's configured now, Addivox is doing something similar, but without an actual low-pass filter. But Addivox is more flexible than just this. I'll go back and flip it around, so higher harmonics come in with a little breath, and low harmonics take a lot of breath. Interesting sound. What if both the low and the high come in at low breath, but the middle harmonics take more breath? Or the opposite, where the middle harmonics come in sooner? A lot of room for experimentation here. I'll return to the more conventional sound where low harmonics come in first and the sound brightens with more breath. On to the next setting. The attack and release tabs go together. Attack controls how quickly the harmonics can rise and level, and release controls how quickly they can drop. I'll set these both to 0 for all harmonics. And then when I play fast notes, Addivox will respond very quickly. And it's responsive to flutter tonguing. If I set them to medium levels, that smooths things out a bit. And if I set them very high, then the response becomes sluggish, but this might be ideal for something like a pad sound. But of course, the curve doesn't have to be flat. I can make different harmonics behave differently, like having the low harmonics attack faster and having the low harmonics release slower. It creates a subtle effect where the note takes a moment to fill out. Now, so far, all of the harmonics are in perfect tune with each other. They're exact multiples of the fundamental frequency, and that means they stay locked in phase with each other. But we can change that in the pitch tab. I can make one harmonic sharp, or set them to a bunch of erratic values. If I go back to the visualization, you can see the harmonics are no longer evenly spaced. Detuning harmonics like this creates inharmonic partials, which can make the sound bell-like or metallic, but as you can hear, it can also sound pretty harsh. The Set Shape menu here lets you choose from some preset shapes. Ramp Sharp makes the first harmonic in tune, and then the higher harmonics get progressively sharper. And this makes them shift out of phase with each other, which you can hear. Ramp Alternating makes even harmonics sharp and odd harmonics flat. But I'll set it back to 0 before continuing. The Pan Edit tab is easy to understand. It controls the position of each harmonic in the right and left channels. It's a subtle effect, but if you're listening on headphones, you might be able to hear this, and you can see it in the visualization too. For a more extreme example, I'll do the full alternating shape, which puts all odd harmonics in the right channel and all even harmonics in the left channel. But again, I'll set this back to 0 before continuing. Now, the remaining tabs all control how aspects of the sound can vary randomly over time. You can control the amount and rate of this variation. I'll start with level variation amount, which is currently all set to 0, so the harmonics have a stable volume. If I set these to a non-zero level, then the harmonics will get louder and softer over time. And like everything else in this video, the controls are per harmonic, so I can make the low harmonics stable and the high harmonics vary. Or make the low harmonics variable while the high ones are stable. The next tab controls the rate of variation, so I can make some harmonics vary faster than others. I'll turn off level variation before moving on. Now, the pan variation tabs. Same idea, but these control how the harmonics shift between right and left channels. If you're listening on a mono speaker, you might not hear much difference, but on headphones, it'll be quite obvious. The last two tabs control pitch variation, how much the harmonics shift, flat or sharp. I'll turn this all the way up, and you can hear that the sound is a bit rougher. And as you can see in the visualization, the harmonic bars wobble just a little bit right and left. This is a good time to mention the knobs down here. Most of the edit tabs we've been using in this video can be scaled up or down for all harmonics with these knobs, so I can take that modest amount of pitch variation and really crank it up. And the same thing for the rate. One final thing to say about pitch variation, since it lets harmonics shift in and out of phase with each other, adding distortion with the drive effect becomes much more intense. So here it is with no pitch variation. I'll play a note and then add drive. here it is with pitch variation. Everything we've done today has affected all notes in the same way, so a high note is essentially a sped-up version of a low note. You can see this in the visualization where the harmonic profile doesn't change with different notes, it just shifts right and left. But we can set multiple keynotes in edit mode to allow the sound to change over the range. To keep it simple, I'll just set one additional keynote down here at C2 and one up here at C6. Now we can edit each of these 3 keynotes independently, so let's give them different level values. For the lowest keynote, I'll make it peak at about harmonic 10 and taper down to harmonic 100. Lots of harmonics work well with low notes. And then, as before, I will smooth it and nudge down the even harmonics for that slight square wave sound. The middle keynote can peak sooner. I'll have it peak at around harmonic 5 and then taper down to about harmonic 50. Smooth it and nudge down the evens. And then for the highest keynote, I'll have it peak at the first harmonic, the fundamental, and taper off pretty quickly. And now the notes are not just pitch-shifted versions of the same note. That's probably enough patch editing for this video. You can, of course, save your patches, and then you'll see them in the User Patches menu, like this. And to wrap up, I want to encourage you to experiment. I'm sure Addivox can make many sounds that I've never considered. As inspiration, here's a quote from an interview with Brian Eno. He said, "This has always been a problem with synthesizers. They always come with a bank of sounds ready-made for people who don't want to learn how to program them, which, it turns out, is most people. So don't be most people, and create some Addivox patches of your own." And in the same interview, Brian Eno said this, "When I'm faced with a piece of technology, I want to know what it can do that the makers didn't imagine it would ever be used to do." So, in that spirit, here is a completely wrong way to use Addivox that I stumbled upon by accident when making this video. You can use the arrow keys to cycle through the patches. But when I accidentally held the arrow key down, I heard this. Have fun with Addivox. I would love to hear your creations.